Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. In this chapter, we are going to discuss the problems in the exercise 7.4. Okay, my dear children. In the previous class, we have completed 9 questions in this exercise 7.4 so far. Okay, my dear children. I hope you have learnt well. Okay, my dear children. Now come to the question number 10, page number 316 in the textbook. Are you ready to listen the class? Right. Integrate. See the question number 10. Integrate 1 by square root of x square plus 2x plus 2. Understood this question, my dear children? We have to find the integral of this function. Okay, my dear children? Right. You know the first step. What is the first step? You have to assume that capital letter I is equal to integral of the given function 1 by square root of x square plus 2x plus 2 dx. But if you observe the function in the denominator, it is a under the square root, it is a quadratic expression. Isn't it or not, my children? It is a quadratic expression in x. Okay, my children. So we have to convert this. We have to convert this function into any one of integral 1 by x square plus a square, or x square minus a square, or a square minus 1 by integral 1 by root of a square plus x square. Okay, integral 1 by root of x square minus a square. We have to convert into any one of that standard integral formula. Okay, my children, because we don't know directly the integration of this function, we have to convert, we have to transform the given function, we have to change the given function according to our convenience. Okay, my children? Right. So that is equal to integral. If you observe, the coefficient of x square is 1. Okay. First of all, it should be noted. First, we should make coefficient of x square is 1. I told you clearly and previously. The coefficient of x square always must be equal to 1. Okay, my children, here what is the coefficient of x square? 1. So, no problem here. Now, we have to write this quadratic polynomial as a square of some function. So, for that, we write x square plus 2x plus 1 dx. Here I wrote 2 as plus 1 and plus 1. Then if you observe these three terms, this is a square of x plus 1 whole square. Can we write these three terms as x plus 1 whole square or not, my dear children? Yes. That is why we wrote this constant term as 1 plus 1. Understood this step, my children? Right. That is equal to integral 1 by square root of these three terms can be written as x plus 1 whole square. Isn't it or not, my children? A square plus 2ab plus b square. It is in the form of a square plus 2ab plus b square, where a is equal to x and b is equal to 1. So, by using that previous knowledge, we wrote these three terms as square of this function x plus 1. Okay, my children? Right. And plus 1 is there. This can be written as 1 square. Okay, my children? Because a square plus 2ab plus b square is equal to a plus b whole square. By using this algebraic identity, we wrote these three terms as x plus 1 whole square. Understood this step, my children? Right. Now, if you observe this function, here I am writing dx in the numerator, dx, integral dx by. Okay, my children? Right. Now, we use the substitution method. What is here? X plus 1 whole square is there. So, to convert this integral into any one of the standard form, let us take x plus 1 is equal to t. Put x plus 1 is equal to t. Now differentiating with respect to t. Okay, my children. This implies what will you get here? We have to find derivative of this LHS part. What is the derivative of x? 1. 1 into plus what is derivative of 1? 0. So I am not writing plus 0 into dx by dt is equal to what is the derivative of t? 1 only. Understood this step, my children? Right. This implies what you will get dx is equal to dt because in the numerator dx is there. So I found dx value. Okay, my children, understood this step? Right. Now we substitute x plus 1 is equal to t and dx is equal to dt in this integral. Therefore, integral dx means dt by square root of x plus 1 means t square plus we write 1 square as it is. Understood this step, my children? We transformed, we converted, we changed this integral into standard integral formula. It looks like a standard integral formula as integral 1 by root of x square plus a square dx. Isn't it or not, my children? Yes. So we can apply that formula. That is equal to, what is that formula? Log mod t plus root of t square plus 1 square. Okay, my children, because integral dx by root of x square plus a square is equal to log mod x plus root of do you remember this standard integral formula, my children? By using this integral formula, we wrote this step where x is equal to t and a is equal to 1. Understood this step, my children? Right. Integration part is over. We have to simplify the answer. But this answer is in terms of t. But the given function integrand is in terms of x. So we have to convert into x. So log mod, what is it here? X plus 1 plus the square root of, again t means x plus 1 whole square plus 1. Okay, my children, we transformed this answer in terms of x. This is the integral of the given function. Okay, my children, this is the last step. So we have to add constant of integration. Understood, my children? Right. Now come to the next question, that is question number 11. Integrate 1 by 9x square plus 6x plus 5. Okay, my children, understood this question? We have to find the integral of this function. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 1 by 9x square plus 6x plus 5 dx. Okay, my children, you know this is the first step. For every question, this is the first step. Okay, my children? Right. If you observe the integrand, in the numerator that is 1, okay. In the denominator it is a quadratic expression in x. So we have to convert, we have to change this quadratic expression. We have to transform this quadratic expression into any one of the standard forms. Okay, my dear children? Right. So for that, first what I said, we have to make the coefficient of x square as 1. Then what is the coefficient of x square here? 9. So we should take it out. Okay, my children. So 1 by 9 integral 1 by, we are taking the coefficient of x square as a common factor from all these three terms. Then what will you get here? X square plus 6x by 9 plus 5 by 9 dx. Understood, my dear children? If you again use the distributive property, 9 into x square, 9x square, 9 into 6x by 9, again we get 6x only. 9 into 5 by 9. Again you get 5 only. That is why understood this question, my children. We wrote this step. So now let us simplify this middle term. 1 by 9 integral 1 by x square 3 2 times 3 3 times 2x by 3 plus 5 by 9 dx. Okay, my children, I simplified the middle term, x term. So 3 2 times 3 3 times. Okay, my children, understood this one? Right. Now we have to write this quadratic expression as a perfect square. Okay, my children, to make this, to write this quadratic polynomial as a perfect square, we follow these steps. Remember these steps, my children. Listen carefully. 1 by, let us consider this is a square, where a is equal to x. Okay, my children. Let us consider second term 2ab, 2 into ax. Okay, my children. 2 into a into, what is b here? 1 by 3. If you simplify, what will you get? 2x by 3 or not? Yes. So a square plus 2ab. What is b here, my dear children? 1 by 3. So we write 1 by 3 whole square plus 1 by 3 whole square minus 1 by 3 whole square. Minus 1 by 3 whole square plus 5 by 9. Okay, my children, understood this step? I added 1 by 3 whole square and subtracted the same number. Okay, my children, plus 5 by 9. I wrote this last term as it is. Okay, my children, to make this quadratic expression as a perfect square, we added this term and subtracted the same. Okay, my children, right. That is equal to 1 by 9 integral 1 by, these three terms are in the form of a square plus 2ab plus b square. Isn't it or not, my children? So these three terms can be written as x plus 1 by 3 whole square, x plus 1 by 3 whole square. Then what is left here? Minus 1 by 9. 1 by 3 whole square. What is the value of 1 by 3 whole square? 1 by 9. Plus 5 by 9 dx. Understood this step, my children? I wrote these three terms by using the algebraic identity a square plus 2ab plus b square, because a square plus 2ab plus b square is equal to a plus b whole square. By using this algebraic identity, I wrote these three terms as x plus 1 by 3 whole square, where a is equal to x and b is equal to 1 by 3. Okay, my children, understood? Right. After that, minus, I wrote 1 by 3 whole square value, that is 1 by 9, plus I wrote the last term as it is. Okay, my children, understood this one? Right. Now let us simplify these two numbers. Okay, my children. Right. That is equal to 1 by 9 integral 1 by x plus 1 by 3 whole square. Let us simplify these two numbers in rough work. In these two numbers, this is a negative number, this is a positive number. First, let us write the positive number. 5 by 9 minus 1 by 9. Now let us take LCM. What will you get in the numerator? 5 minus 1. That is equal to 4 by 9. This is the value of these two numbers. By simplifying these two numbers, what will you get? Plus 4 by 9. I have done that calculation part in rough work. I got 4 by 9. So I wrote plus 4 by 9. Understood this step, my children? Right. That is equal to 1 by 9 integral 1 by x plus 1 by 3 whole square. We got a square of some x, some polynomial. Plus this also can be written, this also should be written as a square of some number. How can we write it? 2 by 3 whole square. Isn't it or not, my children? Can we write it or not? 2 by 3 whole square. Now if we observe this integral, it is in the form of integral 1 by x square. In your mind, assume this entire part as capital X in your mind. So x square plus a square, integral 1 by x square plus a square. What is the formula, my dear children? Yes, 1 by a tan inverse of x by a. Isn't it or not, my children? Do you remember that formula? Right. You apply that formula here. In this step, we apply that formula. Okay, my children? Right. So, by comparing this integral with integral 1 by x square plus a square dx, we get, what is the formula? 1 by a tan inverse of. So 1 by 9 into 1 by, what is a here? 2 by 3 tan inverse of x by a. What is x here? What is considered as x in your mind? X plus 1 by 3 by a, 2 by 3. Understood, my children? Right. Because integral 1 by x square plus a square dx is equal to 1 by a tan inverse of x by a. By using this integral, we wrote this part. Understood, my dear children? Right. Now let us simplify here. 2 1 times, 2 3 times. Then what you will get in the denominator? 1 by 6. 3 2s are 6 into tan inverse of, if you take LCM, 3 is LCM, so 3x plus 1, 3x plus 1 by 3 whole divided by 2 by 3. Understood this step, my children? Right. Now 3 3 gets cancelled denominators. Finally what will you get? 1 by 6 tan inverse of 3x plus 1 by 2. This is the integral of the given function. This is the last step. So at last step, what should we do? We have to add constant of integration. Okay, my children? Understood? Right. Now come to the next question, that is question number 12. Integrate 1 by square root of 7 minus 6x minus x square. Understood this question, my children? Right. You have to find the integral of 1 by square root of 7 minus 6x minus x square dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral 1 by square root of 7 minus 6x minus x square dx. Okay, my children? If you observe, in the denominator it is a quadratic expression in x. Okay, my children? And moreover, here coefficient of x square is minus 1. First, what I said, we have to make coefficient of x square is 1. But here coefficient of x square is minus 1. Okay, my children? That is why integral dx by square root of, I am taking minus common from all the terms. Then what you get? X square plus 6x minus 7. Isn't it or not, my children? Right. But we should not take minus 1 outside, because it is under the square root. Please remember this point, my children. In the previous question, that is a positive number 1 by 9. So we have taken it out. But here under square root minus is there. We should not take it out. Please this notice by my dear children. So integral dx by square root of minus of, you have to write this quadratic polynomial as a square of a binomial plus or minus some square of a constant. In this way we have to convert, we have to change this function. So we can write this one as x square, can be written as a square plus this term, x term can be written as 2, isn't it or not, my children? 6x can be written as 2 into a means x, b, what will get here? 3. Divide this number by 2, then write that number here in the brackets. Okay, my children? 2, write x here, divide this number by 2 and write here in this bracket. That is the value of b. So a square plus 2ab. What is b here? 3. So we should add square of that number minus 3 square minus 7. As for the previous question, we have added and subtracted the same quantity, then its value does not change. Because of that reason, we have done this step. Understood this step, my children? Right. That is equal to integral dx by square root of minus of these three terms. These three terms can be written as x plus 3 whole square. Isn't it or not, my children? These are in the form of a square plus 2ab plus b square. So we can write it as a square of a binomial. Isn't it or not, my children? Right. Minus 9. 3 square. What is the value of 3 square? 9. Minus 7. Understood this step, my children? Right. That is equal to integral dx by square root of minus of x plus 3 whole square minus 9 minus 7. What will you get? 16. Minus 16. Understood this number, my children? Right. Now we multiply by minus. Use a distributive property. Then what will you get? Integral dx by square root of, just we interchange the terms, that is 16 minus x plus 3 whole square. Okay, my children, just we multiplied by minus, then negative term becomes a positive term and the positive terms becomes a negative term. Do you remember these rules, my children? Right. So we got like this. Again we have to write this number as a square of some number. How can we write the square of some number? Yes, 4 square. 4 square is equal to 16 or not? So we write this 16 as 4 square. Okay, my children? Right. See here, my children, what I said, we should write 16 as a square of some number. How can we write it as integral 1 by or dx by square root of 4 whole square. We wrote 16 as square of some number 4 square minus x plus 3 whole square. Okay, my children. Now we have to assume that x plus 3 as capital X in your mind. Then it is in the form of integral dx by root of a square minus x square. What is the integral formula? Yes, sine inverse of x by a. Isn't it or not, my children? Right. Where a means 4, x means x plus 3. Remember this point, my children. So that is equal to sine inverse of x by a, that is x plus 3 by a means here 4. Plus see, this is a last term, so we can add the constant of integration, because integral 1 by square root of a square minus x square dx is equal to sine inverse of x by a. So by using this integral formula, we wrote this step. Integral part is over and there is no simplification part left. So this is only the last step. So at last step we are adding the constant of integration. Understood, my dear children? Right. Then you please try the question number 13 and 14. But a simple change is there in the question number 13. Under the square root, they have not given directly the quadratic expression. The product of two linear expressions are given under the square root. First of all, multiply the two linear equations. Then you get a quadratic expression under the square root. Okay, my children. After that, you follow the steps as we have followed for the previous questions. Similarly, 14th question, same as that of question number 12, same like this. Minus is there. Coefficient of x square is -1. Similarly, question number 15. In the question number 15 also, they have not given a quadratic polynomial under the square root. They have given as a product of two linear factors. First multiply them, then you get a quadratic polynomial under the square root. Then follow the steps what we have followed for the previous questions. Okay, my children. Will you do the question number 13, 14 and 15 yourself, my children? Please do these three questions yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right. Come to the question number 16. Okay, my children. Integrate 4x plus 1 by square root of 2x square plus x minus 3. Understood this question, my children? We have to find the integral of this function. Okay, my children? Right. Come to the solution part. Let I is equal to, capital letter I is equal to integral 4x plus 1 by square root of 2x square plus x minus 3 dx. Okay, my children, we assumed here the integral of this function is equal to capital letter I. Okay, my children, understood this step? Right. If you observe the numerator 4x plus 1, it is a derivative of this function. Isn't it or not, my children? What is the derivative of 2x square? 4x. Plus what is the derivative of x? 1. So 4x plus 1. What is the derivative of minus 3? 0. So finally, what will you get? The derivative of this function is 4x plus 1 numerator. So let us assume that 2x square plus x minus 3 is equal to t. Actually, this question should be given in the substitution, integration by substitution method. In that exercise, this question should be given. Okay, my children. But this question is given in this exercise. So put 2x square plus x minus 3 is equal to t. Okay, my children. Differentiating with respect to t. This implies what will you get here? What I said? 4x. What is the derivative of 2x square? 4x. Plus what is the derivative of x? 1. Into dx by dt is equal to 1. Understood this step, my children? Right. From this equation we find 4x plus 1 into dx value. This implies 4x plus 1 into dx is equal to dt. Now we substitute this value and this value in the given integral. Okay, my children? Understood? Right. Therefore, capital letter I is equal to integral 4x plus 1 into dx is equal to t dt. So dt by square root of t, because 2x square plus x minus 3 is treated as t. Understood this step, my children? Right. This can be written as integral dt by square root t can be written as 1 t power 1 by 2. This is a radical sign. We converted this radical sign into exponential form. Okay, my children, because root a is equal to, this can be written as a power 1 by 2, where a is equal to t here. Okay, my children, understood? Right. This is equal to integral t to the power of minus 1 by 2 dt. Here also we are using the laws of exponents. 1 by a power n. This can be written as a power minus n, where a is equal to t, n is equal to 1 by 2. Okay, my children, understood this step? Now, if you observe in this step, this integral is in the form of integral x to the power of n dx. Isn't it or not, my children? Right. So, we use that formula. T to the power of minus 1 by 2 plus 1 by minus 1 by 2 plus 1. Because integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. By using this integral formula, we wrote this step. Understood this step, my children? Right. Integration part is over. Now we have to simplify it. Okay, my children. So that is equal to what will you get? T power minus 1 by 2 plus 1 by 1. What will you get? 1 by 2 by 1 by 2. In the denominator also we get 1 by 2. Understood this step, my children? Right. This is equal to, we write this reciprocal, 2 into t to the power of 1 by 2. Understood this step, my children? Right. This is equal to 2 into, what is the value of t here? 2x square plus x minus 3. So 2x square, this can be written as root t again, because a power 1 by 2 can be written as root a. Again we are using that result. Okay, my children? That is equal to 2 into root of, what is t here? 2x square plus x minus 3. This is the last step. We converted the answer in terms of x. Okay, my children, understood this step. So at last step we are adding the constant of integration. Understood, my children? Right. You please try the question number 17 also, my children. In the question number 17, in the numerator it is given as two terms, sum of two terms, x minus x plus 2 by root of x square minus 1. Okay, my children. So split into two integrals. Capital letter I is equal to I1 plus I2, where I1 is equal to integral x by root of x square minus 1 and minus I2. I2 means integral 2 by root of x square minus 1. After that, find the integrals of the two integrals, the I1 and I2 values. Find the values of I1 and I2 separately. After that, substitute that values. Okay, my children, will you try the question number 17 also, my children? Try the question number 17 also yourself. Try it yourself. If you have any doubts, ask your doubts and get your doubts clarified. Okay, my children? Right.